I'll talk about our work on modeling relationship in referential expressions with compositional modular networks. Given an image like this and a natural language referential expression like the woman holding a gray umbrella, how do we ground or localize the corresponding visual entities being described in the expression with bounding boxes? Most previous work on grounding or localizing referential expressions often represent the entire expression as a whole, and then match the referential expression with every region proposals in the image. However, it's often the case that natural language referential expressions, such as the woman holding a gray umbrella, mention not only one visual entity, but involves multiple visual entities such as the woman and the gray umbrella, as well as their pairwise relationships such as holding. In this work, we propose the compositional modular networks, or CMNs, to model such inter-object relationships in referential expressions, such as in this example, the woman with a holding relationship to the gray umbrella. Our model explores the compositionality of natural language referential expressions. That is, the meaning of the entire expression can be broken down to the entities and their relationships. In this work, we focus on the pairwise relationships and assumes that the referential expression contains a subject entity, an object entity, and their pairwise relationships. Our model handles the relationship in referential expressions in a compositional way, as it localizes the entire expression by localizing the subject entity and object entity using unary scores, and analyzes their relationship with pairwise scores. Also, our model uses a modular structure. The inference procedure is broken down to subtasks, which are addressed by different modules. Given an image and a referential expression as input, our model outputs a pair of bounding boxes for the subject entity and the object entity in the expression as grounding results. We first extract the set of bounding box proposals from the image, and then 3 self-attention windows are applied on the textual expression to obtain the attentions of the subject component, the relationship component, and the object component. This can be seen as a soft parsing of the expression using self-attention. And afterwards, we first use what we call the localization module to obtain the unary scores of the subject and the object respectively. These scores represent how likely each bounding box proposal matches the subject entity or the object entity. Then we further use the relationship module to obtain pairwise relationship scores on every bounding box pair, representing how likely a pair of bounding box matches the subject-object relationship described in the expression. And finally, the unary subject and object scores and pairwise relationship scores are summed up into the final scores of how likely a bounding box pair corresponds to the subject and the object mentioned in the expression. During training, the entire model can be trained end-to-end. In our experiments on the visual genome dataset, our model can correctly localize the expressions, such as in the upper row wine bottle next to the glass. Also, the self-attention on the test can attend to the corresponding subject, relationship, or object components correctly. On the Google referential expression dataset, for the left example of a woman in a cream-colored wedding dress cutting cake, our model correctly localized the target region described by the expression as the subject, as well as finding reasonable supporting context as the object entity. And in terms of accuracy, our model outperforms previous work on multiple data sets and different tasks. You can come to our poster and check out our code for more details. Thank you.